I want to write what I understand now and not have to be locked into it later. That's what I want. So I don't care about, just don't remove fields. I want to remove a field that doesn't do anything anymore. That's confusing. It clutters up the interface. It clutters up my mind. I don't want it there. When we write software, we want to write against one and only one version of whatever our types are. I do not want the 7 historical versions of this thing leaking into the core of my program. Keeping track of that is complicated. It is a dimension of complexity that I do not ever want to have to manage. The purpose of going schema-driven with this is so that your program can accept any version of the object that was ever valid or was valid after that version of the program itself was written and translate it back to the version that it is written against. Cool. So thank you for the lovely introduction. I'm Sam Boyer. I am nearly an engineer at Grafana Labs. And I'm going to talk about, schemas and this thing called Cuetsy and Thema and a whole pile of other stuff. But I've also learned well enough that, well, let's call this an audience participation night, which is a nicer way of saying I did not prepare a significant and detailed set of slides, so you're going to help me make up for those deficiencies night. But I have some things to cover here, but as you will see, there's a 9-layer stack in one of the upcoming slides that is real, not like a made-up theoretical thing. There's no way that we get through all of it. So I have sort of set us up with a baseline, and I'm hoping that there is enough material here to give a sense that we can do a lot of things with questions. I also have no issue with folks like jumping in with questions as I go. So feel free to do that as well. Cool. All right, so Cuetsy, Thema, and Beyond, Journey from the Bottom of the Schema Stack, and other fun titles. Okay, so, right, I work at Grafana. We do this thing. This is that Grafana is known for. We make dashboards. And so, visualize your data. Technically, we are a, general purpose data visualization platform, but most of our actual business is focused on the problem of observability, aka, who watches the computers to make sure that the computers are always on, because people always have needs and we always have to watch the computers, and you need to, know when the computers are misbehaving. So you have computers watch the computers to tell you when to go after the, right, okay, moving on. So all of this whole dashboard situation since the inception of Grafana, there's no contract. That is to say, dashboards that you go in Grafana and you edit and you save through clicking them together and putting in all of your queries and everything like that, the JSON that is produced has just been an incidental, organically grown, behavioral, complex thing for, well, it was actually, nice little asterisk there, until we started the work of actually trying to schematize it. This meant that, your 10,000 lines of Grafana dashboard JSON that you might save somewhere is effectively just a big indecipherable blob that somewhere several years ago, we went well past any one human actually knowing what all of the things in it do. So, large problem. Why does it matter? Like I said, we get most of our revenue from observability use cases. And if you're going to do observability, that means that you are really trying to figure out how to have a thing ride sidecar with all of the other software that you are deploying, because it is part of doing modern software engineering. You need to observe the software that you're writing. And the main way that you're supposed to do things nowadays is some form of doing things as code. Doesn't really matter what tool set you use. I actively do not care what tool set you use. That's actually part of our sort of whole design approach to what I'm talking about tonight. But yeah, the impact is that when we have no real contract for what a dashboard looks like, the flagship thing that Grafana does, it's pretty hard to make useful tools to do things as code. You can take a giant blob of JSON that you click together in the UI and you can stick it on disk, and then you can pass it along to another Grafana instance, but you can't slice it, dice it, recompose it, do do the things that we're accustomed to doing with Terraform, or I mean, any number of other tools, whatever your stack may be. And this is a big problem for us because this is kind of, like key to our main business, aka allowing people to do observability effectively as an organization. So I joined Grafana Labs August 2020, and I have been working on some form of this, basically since the beginning of 2021. We wrote our first schemas for Grafana's core dashboard as the prerequisite to being able to build up to all the rest of this then. And there's many, many, many different levels at which we could sort of talk about what we're trying to do by schematizing dashboards and all of our other bits and pieces. But I think this is one of the best ways of really distilling it, right? Like platform engineers. If we want to be able to produce a set of tools that are clear enough, precise enough, there's sort of a few things that this goal implies. In order to have a small, reasonably sized, less than 10 people team able to support 2 orders of magnitude more set of engineers actually shipping stuff, there is not a lot of margin for error, and there's not a lot of time for sort of pointless maintenance and weird, toilsome work that tends to come with a lot of observability stuff. They need tools that let them make alerts, dashboards, in standard ways that are tailored to the needs of their organization, that require people to understand really very little about the way that observability works. This whole complicated pipeline of like your application running that emits telemetry data that gets passed through collectors, stored in databases, queried out at different times, visualized. All of this is something that has to mostly be invisible to anyone who's actually going to write an application if you are hoping that you're going to actually be any good at doing observability as an organization, because it's just not as great as it would be. And we do have a sort of 10-year goal type thing. I would love to see doing monitoring and observability as a sort of course we do that in the same way that testing is now the norm, but like 15 years ago, it was not. There were separate organizations that did that. I'd love to see that in 10 years, but certainly the prerequisite to getting there is it has to be as dead easy for anyone working on any bit of software that they're shipping inside of their organization to just make a thing and observe it sanely and correctly. So in order for the team, again, this platform engineer group, to be able to support all their folks shipping stuff and keep that ratio sane, and I just sort of picked these numbers just now, but that seems about right and in line with what our customers are doing. This is roughly the set, right? You need clear and precise and up-to-date documentation. If I have a whole bunch of different fields that I can toggle on a panel on a dashboard, I need to know what they do. And I need to not have just, the few words that a developer could spit out that they stuck in a comment. Like, I need something actually well written in order to understand what the impact of changing a value in this field is going to be. I need a consistent SDK that is in the language that I want to work in, because we as Grafana Labs do not get to choose your DevOps toolchain. We tried a couple times, didn't work. Turns out, by the time that you get to observability, you've already chosen what your stack is. So we just need to work with whatever you do. And that has to be kept in sync with all the new things that we ship with Grafana. We've got more than 100 engineers who work on our front end and various other plugin and data source capabilities. They are constantly putting out new things. There can't be a delay from shipping something to it being available in these SDKs that a platform engineer uses to make Grafana useful for their organization. And also, they can churn all the time. We can churn and add new features and potentially break things all the time. But if we do that, that team of 10 is going to spend all of their time doing maintenance work on a whole bunch of dashboards that got exported and that they don't know what the contents of them are, and it turns into a giant time suck. So whatever gets written out, if you're going to do observability as code, if you're going to write dashboards and alerts and all that to disk in Terraform or Jsonnet or whatever format you pick, that text that you wrote needs to keep working. because nobody can spare the time to actually do the maintenance of like just hand updating thousands of dashboards. And yes, whatever DevOps toolchain. I'm not sure what I was going for with chose us, but yeah, whatever you already chose. So obviously, the solution to this is we should just invent a whole new schema system. I think that's clear, and I can basically just pack up now because, right? Like, totally. While that may not be the obvious solution, that is in fact what we did. So the things I'm going to talk about today are cutesy and like why invent a new schema system, the sort of whole layer, and then talk a little bit about the pieces of the stack that we have, which are kind of the best way of explaining the why. So TypeScript, talking about TypeScript and actually making the connection here. And so Cuetsy is a transformer that takes Q, this language. I will say more about Q in a bit. It's a data constraint language. Takes types, we can call them that in Q, and translates them into TypeScript types. That is basically what it does. So I'm going to show some examples because I think that that's the, again, TypeScript meetup. And also, it's just the best way to anchor everything else because this is really just a small piece of the stack. Like I said, I'll say more about what Q actually is in a bit, but for now, I just want to like throw some code at you. So on the left, we have what you write in Q, and on the right, we have what it produces in TypeScript. And I will remind again, please interrupt if you have questions at any point. Totally fine, since here we're now actually looking at like things. So the basic structure of the way that Cuetsy works is it expects a declaration like an interface that we have over here to then have one of these, they're called attributes in Q, to indicate what sort of thing we want to render it to. And I look at this and this feels self-explanatory to me. Does anyone look at this and like something is jumping out of them as weird? Clearly, Q syntax is, I'm sure. Is anybody familiar with Q actually going into this? I figured not. Okay, or just a teeny bit. Okay, go ahead.
So with the ellipsis you have there, if you left that off, would it become a tuple? Like it would be an array where the first item is number? On the left, you have lists and it's ... number in brackets. If you left off the ... would that become a tuple, like with one member?
Yes, it would.
Okay.
That would be saying that the element list inside of an interface is a one element array or list that the type of the single element must be number.
And can you do like mixed types too? Could you be like strings and numbers in there? Okay.
Q is, and this actually points to one of the things that is a little bit later on, which is one of the reasons for Q is because of how dramatically precise what amounts to its type system is. And that's effectively because it's not actually its type system, it's because of just the entire way that Q works internally. And
also way more readable than JSON schema too.
That is a very good point, yes. Readable than JSON schema. It looks like what you're describing, basically. I mean, if we go back, right? That did not do the thing that I wanted it to. Yeah.
Did you look or just compare to typebox?
What's typebox?
It's very similar. You create types, and then they can convert them into. So you create it in sort of their own language, which is sort of like function-based almost, and it can create TypeScript types, and then can also create Java schemas, JSON schemas.
So is it its own language?
Its own.
Okay, I have a quick call out to Zod later. I will. I looked at a few different things. No, it's totally fine. There's a lot of things in this space, and I will come back to that question because I think that is the reason why item 2 and the things I'm going to jabber about was, but why is largely because this is not a new problem, right? Like, why would you possibly want to invent a new thing in order to do this? Right, so generating interfaces. We can also generate enums. This has some more complicated syntax to it, but still ultimately an enum is a union of different options. And the fact that, enums are whatever, what do you say in TypeScript? It's
terrible.
That's how you say it, yes. That they're not a runtime thing, right? Like they're hiding the fact that it's actually just a string or numeric value underneath.
Can you have it just create TypeScript unions instead of enums?
Yes.
Okay, cool.
Yeah, which is that. Yep. Yeah, I mean, our three top level kinds that you can target are type, enum, and interface. There's also then a very interesting little thing, which is that a native part of Q is the specification of default values, which of course has no direct corollary in TypeScript. So the way that Cuetsy works currently, and there's a small rabbit hole in which we can discuss how this is a fundamentally flawed approach to doing it, and we do have a to-do to fix it, but we represent the default value for the thing being generated as a const. So that, I mean, at this point, it's basically, here's your toolbox. Like, as you are using exported myUnion, also use default myUnion in order to initialize the value of it. At some point, we will have Cuetsy generate functions and some sort of factory-ish pattern that essentially automate the process of initializing new instances of these types. But this is a very interesting property, and we could, the problem of what is the empty value of something is something that goes back. You can trace it back thousands of years in philosophy. It's a ridiculously complicated question. So we could totally spend tons of time talking about this in particular. But it is interesting to note that this is a native part of what Q offers, because it does mean with this native expression of defaults versus using something like if you were to try to write your types in TypeScript, you have no capability of actually doing that, not with the capabilities that the language itself provides you. All right, other questions on these before I go back to non-codish things on the screen, or is this good enough for now? I'm happy to go back to them later too. Cool. All right, so but why? Zod literally exists and is not alone. There's lots and lots of systems like this, and seriously, what is the Q thing and why on earth should I learn another language? So there are a few interesting properties that Q has as a language. Whoops. This is jumping slides. What is happening? Oh no, I guess I put them in the wrong order. Okay, I'm gonna jump back to that one. There are a couple key things the Q brings that are really, really critical for us. It's dynamic. This is not a compiled language. It's written in Go, and you can interact with it programmatically through Go, and we do a lot of that. But it itself is dynamic, so you can just load in new Q stuff at runtime. It is hermetic. There is a just language level guarantee that there is no file system access, no external access whatsoever. Everything that you do is pure. There's sort of an impure operating mode, but it's fundamentally separated in a way that gives Q a very, very nice security boundary. And for a company like Grafana, where we have third-party plugins that need to be part of what we do at runtime, knowing that we can safely run third-party code is a very, very big deal. It has this precise typing we already talked about, right? While I used number back there, Q actually can represent, I don't even know how big its integral range is, but its int type, it actually corresponds to Go's math big, not the normal Go integer. It has a very precise type system that actually goes back to why we can't even really call the things that are there types, but it's a reasonable way of talking about them. It's also very analyzable, statically analyzable. Go ahead.
How precise? Can you do unsigned and signed?
Yes.
In int 32, int 64?
I can do 4 to 7.
You can do what?
I could so 2Q.
Oh, I see.
Yeah, the integer range. It is all just state spaces or value spaces. So the integer range in 32 or U in 32 or U in 16 or whatever it is, those are just bounded constraints on an integral range. And the actual keywords in the language themselves are just, they're not keywords. They're like built-in identifiers that are just aliases for literal constraints that say this value to this value, and you can write your own.
Nice.
It is very analyzable, and that is probably the single most important property for us. But above all, the main thing that we're really trying to do, zooming back to Grafana, right? You have a TypeScript front end and a Go back end and lots of different languages that we potentially want people to do observability things in. Its precision and analyzability means that it is an excellent single source of truth for what our types are. We can encode the right amount of information to be able to really clearly and precisely say, like you can in any sort of decent schema system, this is what my type is. But yes, it also looks like the thing that you're schematizing, unlike JSON Schema or OpenAPI. I don't have a side-by-side of them here, but the difference between, I mean, when I read OpenAPI or JSON Schema, most of my cognitive energy is going to translating the series of nested objects. Actually, who is like tried to read raw JSON Schema or OpenAPI? Who's familiar with this problem? Okay, I'll pull some up because it's yeah, it's worth doing. Hang on. I'm Googling things. Okay, qlang.org/topics. Close enough, okay. They have some lovely things here. I believe, yeah, so here's the side-by-side, right? This is the queue. I want a name field that's a string. I have an optional templates field that is an arbitrarily large list of strings, and I've got max. And then here's what that looks like in OpenAPI. All of my energy is what is being said here. None of it is actually like, what do I want to do on the other side? I really, what I need in this OpenAPI in order to even understand is I need it translated to a programming language that I can work in order to be able to actually think about what I'm looking at here. And Q has some weirdness, which I haven't shown and we're not really going to show unless someone's super curious. In its syntax, it definitely does, but I can read this and I can think about what it means. Straight up, that simple. Okay, so these are the basic things that the Q brings. Do I want to go? No, I'm going to do the stack. Like I said, 9-layer stack. We're not doing all of it. It's crazy. I hope you like my censoring of private information on this image. It's very artful. I know. I'll be taking tips later. But when I say journey from the bottom of the stack, clearly we've started down at Q, and we're going to climb up to Thema, and I might talk a bit about Kindsys. But this here is a diagram, and all of these pieces exist in some form or another. A diagram of the way that we actually break down the layers of what amounts to a schema-driven development approach at Grafana. I will quickly run these through to sort of give a sense of scale, but introducing, it generally takes about 2 days to like run someone through the whole stack because it's still in nascent form and we're sorting out the sort of easier, more digestible public-facing versions of it. Down at the bottom, Q, most analogous to kind of to JSON or YAML, at least if you are making a comparison to like JSON Schema or OpenAPI. And that is the expression language. That's literally the language that people write things in. They write the schemas for their types in our world. Our schema system, which we'll talk about next, is this Thema thing, which is something that I made. And that is most analogous to JSON Schema. It is a system for defining schemas for types, just a fully general system. Our system for what I'm calling schema-driven development, which is really just where you define your types as schemas and you export them, and that's sort of the central piece to a lot of your development work. You have schema registries. This is the way that you sort of coordinate large numbers of teams and also often with customers. So that is what we call Kindsys. This is also public, but underdocumented github.com/grafana/Kindsys. It exists. And this is the core set of rules that really sort of describe how the rest of our system works. If you've worked with OpenAPI, then you understand how an OpenAPI document is basically a bunch of DSL with some schemas in it. I'm gonna, like the OpenAPI spec says, I want to have certain endpoints or certain webhooks, and that's all DSL that's like defined by OpenAPI. So you fill in some fields with what they've written, and then there's certain sections where you write down the actual schemas for the things that are supposed to travel over those webhooks or come in over the API or whatever it is. So it's this like DSL wrapped around a schema system. Our Kindsys is very, very similar to that. Is conceptually quite similar. Also very, very similar to, and in fact, directly exportable to Kubernetes custom resource definitions. Yeah.
So I'm curious, I've heard a couple times now you say something to the effect of like, if you've worked with OpenAPI before.
Yeah.
And in my experience, at least, it's not so much that I work with OpenAPI, it's like I'm writing a Java API and then it exports OpenAPI.
Yeah.
So I'm kind of curious, like, where that comes into play, where you'd actually be like handwriting an OpenAPI spec, or in your case, then a Q spec.
You know, that's actually a really good point. Is that I think that's how most people work with it, and the only reason I'm going to have to amend the way that I talk about this, because when I say if you work with OpenAPI, it's coming out of my experience of having slaved through OpenAPI documents. Poor choice of words. But having had to go through all of that in order to develop adapters and write interpreters for OpenAPI. So I have worked with it in a way that most people haven't, because I do look directly at the documents. But yes, most people don't. And this is actually part of why that difference, where the fact that the queue resembles the actual data, it's a reasonable thing to put in front of people. Like, you can look at this, and even if it's a fairly unfamiliar language, you can pick it up fairly quickly as to more or less what it means, especially when you can then generate it into a language you're familiar with, which is actually a major part of the way that we've socialized it. You want to learn how Q works? Okay, write a thing, generate TypeScript, see what it makes, and then like sort of work your way back. It's a very good way of connecting to the knowledge that people already have.
Going spec first also can have advantages when you're like a multi-language company, where like you could write it from the language first, but if people are starting from the spec, then they have like a shared thing that they're using.
I think ultimately here, it's that people talk about OpenAPI like it's spec first, but it almost never really is. It's exactly what you said. You write your code first, and then your code poops out an OpenAPI schema that you hope is correct, and then like that you hope matches what's on production, but generally doesn't. And I mean, I've seen OpenAPI, or I've seen these specs that are like thousands of lines long, and definitely no human has ever actually looked through them.
That's actually a significant motivator it's one motivator for making a new one, right? One of the ways that I think about this is that the quality of your cross-process communication is going to be, the upper bound is going to be set by the precision of the type system that you use to define the messages that are passed back and forth. So if you're using Go with its lackluster type system, then all of the ambiguities that are inherent in Go are going to end up being ambiguities that get passed over the wire if you write your Go types and then extract OpenAPI from them. Same deal with Java, I mean, whatever language you work in. So this is one of those like, total type system nerd situations where the union of one that like has tremendously precise capabilities and is readable enough for normal humans to use is a pretty potent combination.
Hey man, Go is mediocre by design, all right?
It's kind of the jam, isn't it? Yeah. Other questions before I do just a little bit more of this, because we'd be easy to get lost here. Cool. Okay, so our Kindsys, the main thing that it really does is it defines a few different categories of kinds. We have a few different categories of kinds, which are then implemented in these upper layers, especially this kind producers layer. So in Grafana itself, finally getting back around to like the original problem, right? we have to schematize dashboards. So there is today in Grafana what we call a core kind that represents our dashboards, and it is the canonical schema, and we generate TypeScript out of it, and we generate Go out of it inside of the Grafana repository itself. But we also have various SDKs, including Redacted, that support the development of redacted app and other and other apps that are largely internal right now. Everything on here, with the exception of the one on top, like there's this large series of blog posts which are planned. They're all sort of coming out. There's tons and tons more detail coming from us about all of this in month-ish. We're sort of dotting I's and crossing T's. So we have our core system using these kind definitions, which themselves wrap Thema in the same way that OpenAPI wraps JSON Schema. And then we can take all of those kind definitions, which are defined all across of our Grafana ecosystem, and aggregate them together in order to start generating our as code interfaces. So we have lots of teams who are working on different bits and pieces that interact with Grafana, different Grafana extensions that do one or another thing with your data. And we can fold all of the types that they present together into a giant pile of code gen that lets us essentially just say, okay, we're going to target this language next. So currently we generate Jsonnet, and not directly in this Grok repository, but also TypeScript. And we just pulled out the Go generated stuff, and we'll be putting it back in like end of the month or something. And we also have a bunch of pending Terraform, and we'll continue adding languages. But the entire pipeline of all of our different kind definitions that pass through this framework that we've created all get pushed out to this interface so that we can sort of make these patterns over and over again. A very cool thing that emerged. Well, actually, I'll come back to that, because here's the other sort of funnest bit that we can talk about. So going back to the bottom, right? Q brings some key things, these properties, and it gives us our single source of truth for types. Thema adds more. The will is because some of the, it's work in progress and some capabilities are not there yet. But maybe the most interesting things to point at is this real headbreaker of a line. How can you possibly make breaking changes to schema non-breaking? But that is the main promise of Thema, and the result of it is that our single source of truth for types is no longer just the type as it exists right now. It becomes a single source of truth for types that spans time and space. And I get to say ridiculous things like that make no sense at all, because I'm going to show you what that means. So, a couple of my spectacular teammates for a recent hackathon put together what we call the Thema playground. So Thema is written in Q. It's basically a Q DSL. And just to evidence how quickly all this is moving, this double nested array situation, I literally merged changes last night that changed the syntax to make it less terrible, but we haven't updated the playground yet. So, but this is a Q DSL. And essentially the idea behind Thema is instead of defining just one schema, and then you sort of figure out how you version it and how that evolves over time and what your breaking change guarantees are in some higher layer, you define all of the schemas as you invent new ones, as they evolve, you define them in place inside of one logical structure, and then you define mappings between them. So here we have a very simple case, and I'll sort of show you how this playground works on this in the simple case, and then I'll show you what multiple schemas looks like. This here, it's this actual absurdly nested thing that is the schema. So this is a schema with just a single field, first field, right? And the playground lets us put in a value, and we'll do validate. Come on. Okay, it's not working. Hackathon project. Like 1 week, they threw the entire thing together. This is all WASM, by the way. It compiles Go and spits into the browser, so it's all happening in your browser. So if we hit that, I don't know why it plays back slowly like that, but I think it adds the drama. Maybe it's just the whole, GPT theme that we've got going on nowadays. But this tells us that our input data here matches schema version 0.0. If I wanted to add a new schema version to this, I would say something like this. First field string, and then second field, and to follow backwards compatibility rules. That would have to be optional, right? Because adding a new required field to a thing would be breaking. So now I have two schema versions, and that still says 0.0, but if I add another field, and I hit our button again, hey, look at that. It now matches the next version. In Thema, the main idea really is that we do not want people deciding on what the version number is. The version number should be a function of backwards compatibility rules. Flipping this around, right? Instead of saying, let's put all this sort of effort in at the end in order to make sure that we stick the right git tag on our thing that like correctly reflects the changes that have been made, what if we just declare it in a way where the computer tells us what the version number is? And there is only one correct answer to what the version number is. And the version number for this one is 0.1 because this is a backwards compatible change with 0.0. Make sense so far? Cool. That's all nice and fine, but that doesn't get us anywhere close to being able to make breaking changes non-breaking. So the other major thing that we do in Thema is we have the notion of a lens. And this is also where syntax gets really ugly and is much better in the newly updated version, but I am a disgrace and did not finish updating the playground today for your all benefit. So you'll just have to like check it tomorrow or something, or later this week once we actually update it. So here we have a breaking change, right? 0.0 has just first field, and then we add a new required field, which means that, breaking change. So Thema in the new versions validates that you have a lens, a thing that says, given that I have an instance of 0.0, I want to produce an instance of 1.0. And then also a reverse lens. Given that I have an instance of 1.0, I want to produce an instance of 0.0. So what that ends up meaning is, so we can still run validate any, we get the same results as before, right? Like input data matches schema version 0.0, cool. But if we want to switch to translate to latest, if we send in our same input, then we get out, first field is value, second field is -1. And we can do anything in these transitions that we want. The largest open question, actually, I'm not going to go to that one because it's too much of a jump initially. Questions as to what I have just shown. Should I mess around with this a little bit to show sort of what it looks like to have a weird translation happen, or is this making sense-ish?
Why do you have to have a reverse? Like, don't we want to default to the latest one, and if the data matches an older one, then don't we only want to move forward to the latest one? Perfect question. So when we zoom out and what we think about what having this means, right? The way that I think of Thema is it is something that is perched on the edge of your program. It's not something that you want like inside the business logic of your program. When we write software, we want to write against one and only one version of whatever our types are. I do not want the 7 historical versions of this thing that I have leaking into the core of my program. Keeping track of that is complicated. It is a dimension of complexity that I do not ever want to have to manage as a programmer. The purpose of going schema-driven with this and having the lenses here is so that your program
can attach Thema at the process boundary. Maybe that's HTTP, maybe it's reading bytes off of disk. It doesn't really matter, but bytes come in that are supposed to represent an instance of your type. By having both forward and reverse lenses and the ability to dynamically load in, we call them lineages, the collections here, dynamically load in the lineage that's maybe in a schema registry somewhere, so you can get a newer version of the lineage than your program was written against. Your program can accept any version of the object that was ever valid or was valid after that version of the program itself was written, and translate it back to the version that it is written against.
So data coming in would only be moved forward, upgraded up, but you may downgrade data for the application code to be able to handle it?
So it's really just accept all, write against one. At the moment when you're writing your program, right, you're always writing the most recent version. That's just the way that we develop, right? I'm iterating, I make a change to a field, and so I want to rerun my code gen, and I'm writing against version 2.0. You put that into production, so that thing is running now, and it's written against 2.0 because that's what's compiled into it or whatever. But over time, you add 2.1 and maybe 3.0, new versions of the schema. That program's still running, potentially. Or maybe it's not under your control, right? Maybe it's something one of your customers run on-prem or outside of your control. It is always possible that running version of the program may receive an instance of the object that is 3.0. What does it do? So as long as we're able to hot load into the program, basically it can go to a registry that contains these Thema lineages, and it can load it into the background. It doesn't change any of its actual runtime code, right? This is why it matters that Q is dynamic. We can grab some Q text, and we can take our little Thema thing that sits at the boundary that sees those bytes, and it can say, oh, okay, 3.0, I know how to handle this, and I know how to translate it back to 2.0, the version that this program was written against. Make more sense?
Yeah, makes sense.
Cool.
So as you've been working on this and working on the schema and the layout of everything and having this forward and backward compatibility, have there been any concerns about maintainability of the Q definitions and also speed at which these translations can be done?
Yes.
Yeah. Oh yeah, I assume so, but I'm curious what that thought process was, because theoretically, usually when people are using schemas like this, they're depending on very large and almost inquantifiable amounts of data, and
depends on what you're doing,
yeah.
Right? So the main thing that we're using it for, so despite Grafana being a data-centric company, we are completely focused on our configuration objects at the moment, right? There is a whole kind of other discussion to be had about data plane type considerations. Yeah, so maintainability first. There's a reason that I am apologizing about the crappy syntax that is here. This was the first pass of this that I wrote. First pass in a separate repository, third pass overall. We're now on pass 5. This double nested array syntax was an instance of me thinking about what the logical structure was and just writing the simplest thing that I possibly could. We now have something that looks, I can actually show it. It's not perfect still, but we are only one level nested now, but we've got giant 8-space tabs, and this happens to be under a thing here. Now it's a single layer array. So this is version 0.0. You actually say it's version 0.0, and then the body of the schema is under here, and you can include examples with it. Lenses are written separately, and instead of having a weird reference structure, you just say this goes from this version to that version, and then write your mapping, basically. Not perfect, but dramatic improvement over the weird double nested array stuff. The main next steps, the way that I've done it, the reason I've done it this way is because with the way the Q works, it is no fundamental changes have to be made to Thema in order to basically make a convention where you would put all of the schemas in different files and then the lenses in different files. So that's all doable without any changes to the fundamental system, giving us a concrete target for how you stick the collected set of things together has been my main goal. Yeah.
Is there a concept of but permanently retiring a schema. Because let's say I add a column to my database and it's like a non-nullable field, and I always want to receive this now, and I don't want to just, like, I want my consumers to send this as an important value, and I don't want to just default to an empty string or something for it.
So there's what I heard, like what I interpret as 4 different things in what you just asked.
Sorry.
No, it's fine. But it just reminds me of how much nuance has popped out over the course of working on this, right? At the moment, the whole design of this says, basically, once you've published a schema, and that is an intentionally chosen verb, it's immutable. The whole system only works if once the schema is published, it's immutable. Nothing prevents you. So there's sort of different answers, and there is one answer to this question, which is we do not currently support that yet, and it could run you into a nasty dead end. But like for a lot of the things, you created a field, just drop it. It's fine. Make a new version that gets rid of that field.
I guess maybe this maybe wouldn't be the concern of something like this. Like if there really was a field that I always wanted to be there, I guess in my forward, method, I could put a value in there that in my business logic I would check for to see whether or not I want to support it and maybe return an error or something. But I guess that wouldn't be the concern of this library.
So, and that actually is really kind of critical, because I'm not quite picturing your case, but one of the things that
let's say we receive a request that has like I want to sign the body of the request.
Okay.
And it's really important that we have the signature to verify that this is truly coming from a trusted source.
Sure. So is the question there like that, what is the type of such a field that would be the signature, or?
Like it didn't exist before.
Okay.
And now it exists, and this was like a huge security issue, and we never want to handle a situation where we receive data that doesn't have this new signature in it. But consumers could still be sending it. Would I have to just set in my up or forward? Would I just set a value that then in my business logic I would say, oh, it's an empty string, I'm going to return an error, and it wouldn't be the concern of this library to handle that. Sorry.
So what I have found is that actually trying to lean into this, there are answers to these questions, but I at least get very architecty and engineering and precise as to what I would say the right way to handle it is. The combination of like allowing the sort of translations in place, having default values, and being very sensitive to like optionality versus defaults, emptiness of values, things like that, mean that I would want to ask more questions about exactly what behavior you want to produce and what schemas you have in place already to have an answer to it. There's probably an answer. The only situation that runs you into a dead end for now that I know of is basically one where you accidentally drop a field, you can't get it back. Like lenses work linearly. So if you have fields A and B and then you drop field B and then want field B back, you will lose access to B by the time that you get to sort of the next lens. That's the only actual thing, and we have a plan for how we're going to sort of work around it. So the rest of it is mostly modeling questions that I don't think are actually any different than the way that you would treat things if you are just working with any other schema system, right? What it does come down to, though, is like questions like, do we have like a request versus a response variant for our types? Very interesting question. One of the many reasons why we have sort of focused on the Kubernetes object format as a standard is because there really aren't request versus sort of response forms in a way. There's just the object. And that makes the system less structurally complex because we don't have to like introduce an abstraction that is like 2 paired lineages, one for a response variant, one for a request variant. It is something we can do, we just haven't explored it. Cool. So the magic, the thing that I was omitting before. This goes back to analyzability, right? I don't know if we can do this yet, and I don't know how far we can take it. But with the way that Q works, analyzing for backwards compatibility is like pretty much table stakes. There are some annoying things, like I have to deal with some default value stuff, but it's not hard. Actually, literally the entire way that Q works is around a mathematical operation that amounts to checking for backwards compatibility. So it is like foundational to Q. What is really interesting, though, is the possibility that we could prove that all of the lenses in a lineage are sufficient to produce a valid object of the schema that they target, given a valid input of the one that they're coming from. Because if you think about that, that means if we can make that as a fully general proof, it means you literally can't write a valid lineage that would ever pass any checker ever that doesn't give you that full translatability back and forth, full time travel capability for your program floating off in the ether, receiving messages from wherever. It's just native. And while I can imagine other schema systems adding something like a lens capability, the ability to do that proof is fundamentally linked to the expression language that these things are in.
Can you go back to the example of a lens?
Yeah.
I forgot what it looked like.
Sure. Let's do this. Why did it again?
Okay, so it's still not like Turing-incomplete. Like you're...
No, it's correct. Q is not Turing-incomplete.
Okay.
Crucially, not Turing-incomplete. So right, so the analysis here would be basically, if this is the whole mapping, which it is, that takes us from version 0.3 or to version 0.3 from version 1.0, do we cover all of the fields that exist in version 0.3? Do we cover all of the possible input values that are acceptable in 1.0? And does there exist logic for the whole state space that is specified as possible for 1.0?
It's not static, but could you use a fuzzer to validate?
I mean, you could certainly, you could probably test the completeness of your logic, but it's a different class of check, right? You know, a proof versus a brute force check, essentially. And the reason why Q can do it is because of its internal type system. That's what they call the value lattice. The whole system is based on this like lattice representation of values that put them all inside of the same, like types and values are actually the same thing. And it has this precise internal concept of what the acceptable state space is, so that it's maybe possible for us to, I'm sure that we can do lots of checks. I don't know how complete we can make them. That's the sort of unknown at this point. Cool. Right, so the main thing that this gives us, going back to, did I write them down here? Yeah. So since our goal, again, right, the platform engineer, the overworked platform engineer who has this huge array of like objects that have been generated by all of the engineers that are depending on the stack that they've made, the ability to have schemas where the Grafana folks who have written the lineages and they write the lenses, and we can potentially even check the completeness of the lenses, and we can bundle all of that up and stick it into a CLI or all of our as code tooling, so that's just a native part of like what you get when you spew JSON out to disk and then consume it through Terraform or through Go or through whatever your DevOps tooling of choice is. It means that there is a nuanced early feedback path when there are problems that have to be resolved, because we can basically do the migrations in place. You don't have to have Grafana running in order to do the same migration that Grafana would do. There is an asterisk there, but it is not, it's a very important asterisk, but I don't feel like we should go charging into that right now. So it helps enormously with this backwards compatibility thing. It relieves the tension between the folks working at Grafana who want to iterate rapidly and add new features and potentially, a friend of mine actually put this to me really well. Like when I told him about Thema, he said, oh, so what you're telling me is that feeling that I get when I start a new project and I'm like, what should this type be? I know that I have no idea. And I know that as soon as I write it down, it's going to be wrong. And I know that I'm only going to find out by sort of messing with it. And I know that as soon as I write it down, it's public. And so technically, if I change it, It'll be broken. You're telling me I don't have to worry about that anymore? Yes, that's kind of what I'm telling you, right? So our developers can iterate freely and focus on only having the things in their types that are actually a representation of the way that they think, no cognitive overhead. And we can still maintain a stable, importable interface for our people who are actually depending on the software on the outside. Also, lots of crazy things about the way that you can compose defaults and do like templates and policy things. And then, yeah, have it in your language of choice. This is how we hit all the goals. That is all I have.
So as you're talking, I keep thinking, so Protobuf has a schema registry.
Protobuf, right, yeah.
Protobuf is language agnostic. It has retiring fields. And Protobuf has backwards change, like breaking change detection.
Buff does, yes.
Buff does.
Right.
Right, yeah, sorry.
Yeah.
The buff registry, I think of them as the same.
Right.
Sorry. I'm just curious if you guys considered Protobuf, because it feels so similar to what you're showing here. And I guess the only thing I can think of that doesn't really have a corollary in Protobuf is the default.
Well, the defaults, there's no lensing though.
Yeah, there's no lenses.
Right.
Are there nullables?
No. Protobuf takes a different tact, and Protobuf's not alone. In Protobuf, all fields are optional all the time. Deal with it. And this is a... There are default values, yes.
What if like 0 means something in your application?
I know. Yeah, the problem is there are ways to actually tell the presence of fields, like to tell whether or not it was passed, but they have default values, so it can never be nullable. Anyway, Protobuf aside for what we're talking about, but I'm just curious if that was something that you guys looked into or, yeah, I don't know.
Little thing to add there real quick before I give the answer is, I learned recently that apparently the reason that Protobuf does not have default values is because Rob Pike ranted about it at Google like 10, 15 years ago or something like that, and said default values in your whatever process boundary crossing thing are a terrible idea. And I have yet to get a text of that rant, and I would love to see it because I don't agree. And
there's the closest thing I can tell you. Don't be nice to Rob Pike. Okay. Kenton is the guy that made Proto 2 and is not the Proto 1 guy, but he ostensibly made what Protobuf is today. He has lots of things on Hacker News and all over the place on Twitter as well, ranting about exactly that fact about how when you're thinking about data structures in the moment, of course, like them always being optional sounds silly. Like you want required types, but when you're talking about data structures changing, like schemas changing over time, then like I can't spit out all the paragraphs, but anyway, at the risk of standing on the soapbox about that, I'm just curious, like if that was something that you guys discussed or if it was something that came up.
Yeah. So no, I mean, the path to this, I joined Grafana. We had a set of things that were basically reusable packages of objects written in Jsonnet. Today, our one-click integration things in our cloud are powered by these same things, our cloud integrations. These things are called mixins or Prometheus monitoring mixins. The name is a weird history. But I got that bootstrapped, and then I looked at it and I said, I can't make anything with this because it's working on sand. There's no schemas anywhere. Jsonnet's, if you've never worked with Jsonnet, it is one of these sort of templating, scripting-ish languages. It's derived from GCL at Google, or it is GCL, just an open source version. And its whole operation is merge. That's what, the whole thing is built around the merge operation. I have a structure, I'm going to merge other things on top of it and override what is in the original structure. And the effect of that is you never have any idea where any value comes from, or nothing is actually fixed and nothing actually has to follow any rule because you can just change everything at any given time, which is very convenient and also makes for a terribly unintrospectable language. Q came to exist because the creator of Q was one of the original creators of GCL and did not like it, and did not like that about it, and he wanted to make a better one. So he started working on Q, and then he left Google a couple years ago. And he's now just working on this. So I was interested in Q as a way of making the configuration language, like for the as Cody story, better initially. I ended up staying with Q, not because, I mean, actually, realistically, there's a whole bunch of interaction between Thema and Proto that needs to happen, and I've talked to a few of your folks about building that integration. There will be an interesting conversation to have someday about schema registries. But ultimately, like once I started putting together that it was conceivable to do the lens completeness proof, and the way that I had this like what you see is what you get thing that I touched on a few times about the type that you actually write. And I realized that we can still always generate proto, like coming out of it, right? That like this is the form that I wanted to originally write it in. I do not think that Q is the most efficient or anything like that ever form for doing this processing. But if it is precise enough, and if it can do these proofs, then everything else comes downstream. Like we can make breaking changes. So imagine it this way, right? Like you have some proto that you've defined. You're going to generate some endpoints, and in order to not ever have to like make new endpoints, you have to never break any of the rules around backwards compatibility in order for that to continue to work. And sure, like you could make up your own silly little convention about like, we're gonna stick V2 at the end and then follow that in order to find V2, right? And as long as you're just making it up yourself, that's a silly little convention that doesn't mean anything at all, and there's no guarantees that come with the relationship between those things. But if you do that same thing and you generate the entire thing out of Thema and you stick the lenses in on the other side of the receiving end of the messages, now you can use Proto for your communication layer. It's predictable what all of the different endpoints that you're going to generate are going to be between all of your counterparties, and you can still have the one type that you wrote your program against on the other side. So it is like, I think that I am super happy with, and in general, like totally fine with Proto as the actual means that we would want to do a lot of communication over. But to me, this is the better expression form.
I'll take it. Cool. Thanks. That's a great explanation.
I have so many questions. Okay, so another thing that I'm starting to get interested in with this is a lot of that last bit of the slide was talking about wanting to maintain compatibility for like older versions of a front end. It seems like maybe the front end's V2, you got a V3 now, and your API is V3 and your app's V3, but somebody has like cached the page somewhere, and so they want their apps to still work on V2. My understanding, and I know I might get some Dimitri flack here.
I'm maybe not saying that, but that's actually fine. Go ahead. Go ahead.
I might get some Dimitri flack here, but I'm a GraphQL fan.
Yep.
And at least from my understanding of what like GraphQL pitches, they say if you write a GraphQL schema, you should never have to worry about backwards compatibility, because the only issue you'd ever have there is like if you get rid of a field, right? If the new like V3 no longer has the field, sure, your V2 would break, but you should never need to do that, so you're fine.
Every argument about backwards compatibility ever, I've worked in like package management and such for a long time. Every argument at the end of the day comes down to just don't do that. I don't find those arguments convincing. I never find those arguments convincing, and I will never find those arguments convincing. Like, it goes back to what I was saying before, right? About, just picture the like blank or near blank page of your editor, and you are writing a new type, and you are trying to think of what to name the fields and what they should be. And I don't know about you, maybe it's just my like, perfectionisty whatever, but like the abyss opens up in front of me. And I try to predict and imagine what is going to happen with this thing and where it is supposed to go. And I don't want to think that way. I don't want to have to rely on, just don't do that. I don't want to have the detritus accumulate in the program that I'm writing. I want to write what I understand now and not have to be locked into it later. That's what I want. So I don't care about, don't remove fields. I want to remove a field that doesn't do anything anymore. That's confusing. It clutters up the interface. It clutters up my mind. I don't want it there.
And then to the second part of that, so let's say, okay, we're going to remove a field. We have a V3.
Yeah.
We want to break the app. And in this philosophy, the designer's like, we don't care if somebody has V2 cached out there. We want that to break now. So like, is that a workable philosophy, or do you, is part of the reason of building this that you also really think that people should be trying to keep all their front ends working throughout time and space?
So this is the key. I'm not actually arguing that. What I am, and I'm not saying that your application should continue sort of supporting all of its old modes or anything like that. It's really, really, really about change management. I am perfectly fine with you having like old versions of your application that you don't want to support anymore. So I worked at Stripe, right? One of the things that Stripe is super known for is the fact that every form of acceptable payload you could send to its create charge endpoint, the main way that Stripe makes its money, they still work. 15 years later, all of the old payloads still work.
Is that what you're inspired by Lens? Will they like upgrade up and then
Yeah.
upgrade back down?
Yeah. They accept all the forms, the like request, I don't even know how many things I'm supposed to say about it, but like it is certainly a known thing that like they offer this, and there's whole sections of their docs that are dedicated to explaining, here's the changes, here's the sort of transforms that go on, right? This is a cornerstone of like Stripe's business effectiveness, that we don't reject things that were once valid. That doesn't mean that we are going to preserve all behavior. And this is one of the really interesting things about choosing to focus on, I think, schema, right? Is that all right, it's not the time for that. By choosing to focus on schema, by choosing to focus on the message that is sent, right? We are not saying that we are going to have all the same behaviors in place. No, it is the right time for that. There's this thing called Rice's Theorem. Rice's Theorem is super cool. It's one of these early theorems from computer science. And it says that only syntactic properties of, I'm gonna look it up again because I just stumbled myself on it. Rice's Theorem. Any non-trivial semantic property of a language which is recognized by a Turing machine is undecidable. Any non-trivial semantic property, any behavior. Really, all this is saying is it's just basically a restatement of the original halting problem, right? You can't write a general algorithm that figures out whether or not a program can halt, and therefore you cannot write a general algorithm that figures out whether or not any given behavior exists in a program, because to do so would be to definitively tell whether or not the program halts. Can't do it. What you can do is analyze syntactic properties of programs, which we all know. What we intuitively know, what we call semantic versioning, and what we have all sort of gradually come to learn of the rules that you follow in semantic versioning, have nothing to do with semantics. They're syntax. They're talking about whether or not you've added a field or not. These are statically recognizable properties of programs. That's syntax. It's not semantics. So, sorry, this is a thing. I need to this is the Boyer corollary to Rice's theorem or something, and I have to write it up at some point. It's interesting to talk about schemas because we can say something more nuanced and precise about the semantics of a program by restricting the language that we use to the syntax of the message you use to interact with it. If I eliminate a field from the message that I take, to do a thing, perhaps I've deprecated it already, perhaps it was a no-op or whatever it is, but what we're really communicating to someone who sends us a message is, we don't have this behavior anymore. Like, I'm not gonna get rid of a field that's associated with a behavior that's still there unless it's a mistake. So what's interesting about, what I think is interesting about Thema as a system, and there's a thing in here that I didn't talk about that I skipped past. There's this thing called lacunas, which are basically something you can put on the lens. Lacuna is a term from translation theory that basically means a gap in translation. Thema is all pure, right? It's hermetically sealed. Q is hermetically sealed, so you can only do pure functional transformations. There's classes of things that you will never be able to do in lenses. That's by design. It's understood. Lacunas let us say there's a gap in this translation, and then whatever program is running the lens sees the lacuna and can respond. I have to do a database lookup in order to fill in a field, for example. That's something that if the program that's running it has access to the database, they can do that. Otherwise, we can just emit the lacuna and sort of tell the user. So between the lenses, the removal of fields, other attributes that we can add, lacunas, there is a nuanced system for communicating to the consumer of your API, we're getting rid of this behavior. That's much better than a change log or whatever else that people don't see. And it's especially the case if, I was just actually talking to one of my coworkers about this earlier today. We're working on a lineage. We're going to add some new schemas to it, and we've chosen to get rid of a field. Have any of you ever run, like, you know, in your CI, you like turn on the tip version of the language because you want to see if your program, if all the tests still pass against like the latest thing that's coming from the language that you're working in, right? You can do the same. You can, with whatever as code tooling you're using, all the objects that pass through it, proactively update them to the latest version that was published. Don't actually have to do it, just see if any lacuna get emitted. Is there a problem with any of my objects? Now I have advanced warning. I don't have to read change logs. I don't have to do anything else. I have this communication channel directly from the upstream developers that is nuanced and specific to my literal object. Not even like, because the lacunas can be written in such a way where, you know, I have a case that I can point at that makes them pretty clear, at least one of the use patterns. Oh God, I'm on, all right, somebody's gonna have to shut me up because I'm on the soapbox now. But so this happily has been rewritten in the new form. Two schemas, right? 0, 0, and 1, 0. The initial one has a boolish field, which is like a YAML-y bool, right? You can take the string true and decide that that actually means bool true because YAML's a great idea. And then in 1, 0, it's actually like a proper bool, okay? So the lenses, what we encode in the lens logic is I want my proper bool to be true if and only if it is literal proper bool, because we accept booleans. So if it's an actual true boolean, cool. And then I want my translated proper bool to be the boolean true if and only if it is the string literal true. If it is any other string, I want it to be false. But we can emit a lacuna. And this is actually supposed to be moved to a condition field, but my automated rewriter does not do that. So if the input for the field is a string, and it's neither true nor false, people have jammed some garbage in there, right? Then emit a lacuna. So you don't get a lacuna out if there's a string false. We know what we want to do with that. But if you have some other random garbage in there, then we actually emit one of these. So the lacuna is conditionally emitted. It's only emitted in the case where basically we know that there's going to be data loss. It is specific to the particular object that's being passed in. So it is this nuanced communication mechanism between, I think, the publisher of the schema and everybody who's depending on it. Dear God, I could go all night. I feel like we should go to the bar or something.
All right.
Thanks, everybody.